Welcome to our video lesson over a line of best fit. We're going to be talking statistics. Be sure that you have your Desmos calculator open and ready to get started. What is a line of best fit? Well, it's when we have actual data from a table, so real life data, and that data creates a scatter plot. We know that all those points on a scatter plot, the chance that they form a perfect line to go straight through all of them is super low. It's just actual data. It's not going to be perfect. And so, since actual data can be pretty messy, we have something called the line or the curve of best fit in order to sort of fit to the data the best. And that line gives us a nice equation so that we can make predictions and answer questions from our data. Let's think about an ice cream shop. We'll say Jane's Ice Cream. And they want to know, is it really worth it for them to be open when it gets pretty cold, like in February? So, what they did is they took the average temperature for the months that they are open or just on certain days. And they found the sales of ice cream that they made based on the temperature of that day. So, again, this is in Celsius, but I did change it to Fahrenheit for the data we're going to use. So, we saw that when it's 14.2 degrees Celsius, they made $215 in sales, and so on. And so, using this data, we can find the line of best fit and make a prediction. Is it worth it for Jane's to be open in February when the temperature is so and so or super low? How do we do that? Well, first we have to create a table in Desmos. So right now, go ahead into Desmos, click the little plus sign, and create a table. You'll see an option there to add a table. It will come up as X1, Y1. If you ever want to type X1 or Y1 in Desmos generally, which we will, you don't need to do anything special to get this subscript. You literally type an X, then a 1, or a Y, then a 1. But this will already come up for you. So go ahead and take a moment to do this and enter all of this data into the table. Be careful. Make sure you are being very detail-oriented when you add it. And go ahead and do that now. We can see here that we do have all of our data on the screen. Now, what if when you started, you probably didn't see all of that data. You probably didn't see any of it plotted. You didn't see that scatter plot there. This green up here tells us that those points are going to be green. You can change the color if you'd like. But we can see here that I don't see any of the data points initially because my window is not big enough to see all those data points. Note that all of our X coordinates are kind of large. They range from about 50 something to almost 80, right? Our maximum X value is 77.2. And so we have to make sure that that is accounted for. Here, I only can see X coordinates from 0 to 20. So go ahead up to this graph settings up here. And let's make our X minimum -10 so we can see the origin there. And let's make our X maximum 80 or 90 because our biggest X was 77. Now I still didn't see my data because we have to account for the Y. So our Y coordinates are pretty large. Remember, they represent the dollars that have been made that day. So sales. And it looks like they go up to 614 is the maximum. So in our settings for the Y-axis right here, we want to make our Y maximum maybe 700. Now, when we do that, we're going to see all of our data. And from there, you can zoom in and out as needed. So there we have that. Now, how can we get a line of best fit, right? If I tried to connect all these dots, it would look super messy. It wouldn't make a line. And it's not helpful to have something that looks like this. That's not any sort of equation that I can capture in a nice y equals mx plus b. And so what we are going to do is we're going to find the line of best fit using Desmos. So here's what you need to type into Desmos. You're going to type, instead of y equals mx plus b to get the line, you are going to type y1 squiggle mx1 plus b. This is what you're going to type into Desmos in the next line. So let's do that together. So down here, I'm typing Y, then the number 1. That's telling Desmos to use those Y1s we have in the data set. Then the squiggle, which is up under the escape key in the top left. Make sure you hit shift and then click that. Then MX1 plus B. And look what it did. It made this nice line. In this case, mine's red. Again, you could change the color. But it goes through our data in a super nice way. It's actually the line that best fits our data points. And so we can see, what is the equation of that line? Well, if we zoom in just a bit over here, we'll see that the M and B are given to us down here. M is 16.7. I'm just rounding. M is 16.7, just rounding. And B is negative 693.8. Again, just rounding, so we don't have that many decimals. So let's go back. And so we entered our data, we saw the scatter plot, and here's how we did it. We put our data in the table, we typed Y1 squiggle MX1 plus B, then it gave us the M and the B. And so using Y equals MX plus B, we replaced M with 16.7, what it is, and we replaced B with negative 693.8. Again, I rounded. So that is our line of best fit. That is the line that best shows the relationship for Jane's ice cream of the temperature versus the sales. So now we can use that line to make predictions. Like, should Jane's open in February? Here's the question we want to ask right here. And here's our line of best fit. I already have it written. We want to predict the sales when the temperature is 45 degrees. We want to predict the sales when the temperature is 45 degrees. So recall that temperature is the x coordinate. We are going to just plug in 45 for x. We can use Desmos to help us with this. So we're going to have Y equals 16.7 times 45, right? We plugged in 45 for x, minus 693.8. It gives us our output here. So we input the temperature, those were the x coordinates, and it output Y, the sales, or the predicted sales for that. Let's take a look here. Oh, we saw the answer is $57.70. That's pretty low. That's pretty low. Looking at our line of best fit here, when the temperature is 45 degrees, we're approximately right here. And that on the line is the coordinate point 45, 5750. Now that makes sense with our data. We had data that showed higher temperatures and higher sales, but our line of best fit is predicting when it's 45 degrees out Fahrenheit, the sales that are predicted to have been made are $57.70 using Desmos there. Okay, next up, we're going to do some practice. So go ahead and find the line of best fit for the data. Recall that your first step is to make a table. Now, my advice to you is to clear the data that you had in the other table, so that, because if you make more and more tables, Desmos will use X2 and Y2, X3 and Y3, and so on. You want Desmos to just use X1, Y1. So just have one table in there at a time. Go ahead and input this for X1 and input this data for Y1. So here we have it. We have our data in. Then we used our Y1 squiggle M X1 plus B, which is just Y equals MX plus B, but it's using X1 and Y1 data instead of just X and Y general. And the squiggle means give me this predictive line of best fit. Now this data is super nice. Look at how all the data points go through this line. So our line of best fit is Y equals negative 19.06. Again, I rounded with the M. X plus 243.87. There we go. Can we make predictions from this data? We want to know how many complaints can the company expect to get in the 8th week? Well, in the 8th week, that would be an X value since week is the X value. So we're going to plug in 8 for the X value here. Using Desmos, we can plug that in, and we're just simply plugging in our line of best fit, except we're replacing X with 8 since we're asked about the 8th week. It outputs our answer of 91.39. Well, that means it's about 91 complaints. Complaints have to be an integer value because a complaint can have half of a complaint. So we can see that that makes sense here. As the weeks go on, the number of complaints have been going down. This scatter plot here, without the line, has a negative correlation because from left to right, the values are decreasing. So we can see that in that our slope is negative. And so it makes sense that after 8 weeks, we continually go down with the number of complaints. So there we have it on using a line of best fit for our data. Put the data in the table using X1 and Y1, then type out Y1 squiggle mx1 plus b. Here's your m and your b. Plug it into y equals mx plus b, and that's your line of best fit.